Here's another problem in our chain rule section. This does involve compositions, but when I look at this problem, r equals sine of theta squared times cosine of 2 theta, I recognize that this is really a product. This is really the sine of theta squared times the cosine of 2 theta. So we're going to follow the product rule, and then along the way we might need the chain rule because they do include compositions. So the product rule works something like this. I get organized by doing my u and my v, and my u prime and my v prime. So u is the sine of theta squared. U prime has a composition here. So keep in mind, and I'm going to change color here for a second. Let's see if I can erase this. Theta squared is a function in and of itself. It's a power rule function. So when I do the derivative of u, it's going to be the derivative of the sine of theta squared times the derivative of theta squared, right? So that's going to be cosine of theta squared, right? That's our u when we do the chain rule with u substitution. And I have to multiply that by the derivative of theta squared, which is 2 theta. So when you write out this u prime for the product rule, I would write 2 theta cosine theta squared. And this is the chain rule piece right here, this 2 theta. That's what drives me crazy when I'm grading problems and people don't follow the chain rule. V is going to have a similar situation. If V is cosine of 2 theta, and I'm writing that in a different color because that's a function in and of itself, V prime is going to be the derivative of cosine of 2 theta, which is negative sine of theta, negative sine of 2 theta, right? But then I have to multiply by the derivative of the sine of 2 theta, which is just 2. And so when I write this V prime, I write negative 2 sine of 2 theta. That's the derivative of cosine 2 theta. The derivative of the cosine is the negative sine, and the derivative of the 2 theta is 2. So again, there's this little chain rule piece right here, this 2 that we have to make sure is included. Once you have u and u prime and v prime, you can go right to the derivative and write out your product rule. So r prime, which is what we're trying to find here, right? Here's our function r, is going to be sine of theta squared times negative 2 sine of 2 theta. That's your uv prime. And so that's going to be, let's just rewrite this as negative 2 sine of 2 theta times sine of theta squared plus 2 theta times cosine of theta squared times cosine 2 theta, right? Because that's v. And I'm just eyeballing this to see if there's any, the only real thing we could do maybe is factor a 2 out of there. I don't think that's necessary. Yeah, off the top of my head, I don't see any identities that we need to employ here to simplify this thing. I'm going to call it good right here. We can argue in class about whether or not we can make this simpler, but the bottom line is I came up with a derivative formula. If I'm able to simplify this, it's just showing off, and it's not necessary for what we're asked to do. We were asked to find the derivative of r, and we followed the product rule. Along the way, we did need the quotient rule, or excuse me, not the quotient rule, the chain rule. Geez, the chain rule. So these stars are the chain rule. Each of these individual factor functions were compositions, so finding their derivatives required the chain rule. But then when you put them all together, you still follow this product rule. So this thing's a product. We wrote it out. I think we got it. And I'm going to cancel the video now before I talk too much. If you have questions, you know where to find me. Take care.